So as I told you, in our unit we mainly concentrate on the cubic unit cells. Cubic unit cells, hope you remember, the cube is made up of, see, yesterday I showed a model, hope you remember. So consider this is an atom. First atom, second atom, third atom, the fourth atom. If I arrange these four atoms, I get a square shape. If I draw a boundary, I get a square shape. And if I place four more, see these are the two and two more. So I have, consider I have 8 atoms. I have 8 atoms. So these 8 atoms constitute a cubic arrangement. How? So if you observe from this front side, you have one square, back side square, right side one square, left side one square, bottom one square. So we have totally 8 atoms. They are enclosed in a square arrangement. So let me illustrate this in the figure. But this is the actual 3-dimensional arrangement. But in the board, we have to represent only like this. So one atom is here, the second atom, third atom, fourth atom, fifth atom, sixth atom, seventh atom, and eighth atom. Remember, this is the edge length. This represents edge length. So this is simple cubic. This is primitive unit cell. Assume next unit cell. So I have same 8 atoms, same lattice points, cubic arrangement, but another atom is present in the body center. How? So let me illustrate. So I have 4 atoms here. 4 atoms here, and I have another a smaller atom. So this atom is going to be placed in the gap between the 4 atoms. It's a square, and if I arrange the 4 atoms, a square is, a hole is produced. So I keep another atom here, and the other 4 atoms like this. Where the small atom is situated, it is in the body center. So in the board, I can represent only like this. This is called the body centered cubic. Body centered cubic. The third one is we have the same cubic arrangement, 8 atoms on the corners. I illustrated the faces. So we have 6 faces here. This one at the back. This one, the front face. This in the right side. This in the left side. This in the top, and this in the bottom. If atoms are present, where, see, these are the 8 atoms. Where are the faces? This is the front face, back face, right face, left face, and bottom. 6 faces are there. Now atoms are present in the center of the face. So we have 6 faces. That means 6 atoms can be accommodated at the face centers. So this can be represented like this. So where is the other atom? At the face center. Face center, this is one atom. Face center, second, third, fourth, fifth. This is at the back face. This is at the front face. This is called the face centered cube. So this is primitive. These 2 are non-primitive. These are the 3 cubic unit cells. Students, the unit cell is the basic repeating unit I told you in the crystalline solid. So let it be one unit cell. Here atoms, so this is a simple cubic, consider. One atom present at the corner. So let it be an atom, this is present at the corner. Likewise, we have atoms at the 8 corners. Only one unit cell is not present in a crystalline solid. Millions and millions of unit cell. See, let it be one unit cell, second unit cell, third unit cell, fourth unit cell. Likewise, unit cells are present in 3 dimension. What do you mean by 3 dimension? So, unit cells are present in the right side, in the left side, in the front side, in the back side, at the bottom, at the top. Likewise, we can go on building the unit cells. See, go on building. Likewise, number of unit cells are arranged. Number of unit cells are present. Atoms are present at the corners. So you can have millions of unit cells built in 3 dimensions. X-axis, Y-axis, Z-axis. So number of unit cells means millions of unit cells are present. Next, we move on to the next topic. Calculation of number of atoms in a single unit cell. In a single unit cell. You may think that, let me assume the simple cubic. You may think that 8 atoms are present in the simple cubic unit cell. Of course, 8 atoms make the cubic shape. So one atom at the corner, second, third, fourth, fifth, sixth, seventh, eighth. But actually, one atom is not exactly present in one unit cell. One atom is actually present in 8 unit cells. How? So I will show you. See, this is an atom. This is present in the corner. Means, see, this atom is present now in the corner of a unit cell, but it is lying, but it is shared in the 4 unit cells. Can you see 4 unit cells? 4 unit cells. Not only 4. If you see, so 4 more. So actually, this atom is present in 8 unit cells. So an atom at the corner is not present in one unit cell. It is actually shared by 8 unit cells. So this atom present in the corner is shared by 8 unit cells. So one atom is not available, it's available 1 by 8 part only, 1 by 8. So consider, I have an apple and 8 students are sitting. I want to give this apple to all the 8. How can I give? I cannot give one apple to one person. I want to give all the 8. So what should I do? I should cut it into 8 equal parts. And I can give 1 piece to each one. So I am giving 1 piece to each one, 1 apple given to all 8. So what is the share of 1 person? 1 person gets only 1/8. So like that, 1 atom is getting 1 by 8 share only for this unit cell. So in the simple cubic, we have 1 by 8 portion of 1 atom only. So this is share of 1 atom in the simple cubic. So this is going to be used later for the calculation. So a corner atom in the simple cubic unit cell is shared only by 1 by 8. So next, coming to the body centered atom. So this is corner atom. Body centered atom is well present within the unit cell. It is not shared. It is present at the body center. So it is not shared. What about the atom at the face center? So if you consider an atom at the face center means, see, this is a face. If an atom is present, only half of the atom belongs to this unit cell. Another half belongs to next unit cell. So an atom present at the face center, only half is available. So this I can summarize. See, an atom at the corner. is shared by 8 unit cell. So for this unit cell, 1/8 part only available. Atom at the phase center shared by 2 unit cell. So one atom is shared by 2 unit cell means for this unit cell, this atom is available only half. But whereas an atom present at the body center is wholly, totally present in this unit cell, it is not shared. So 3 types of atoms I told you. Based on this, we are going to do one calculation. Wait for some time. Next, we are moving on to calculation of number of atoms in cubic unit cells. Why we have to calculate number of atoms in the unit cell? So only by knowing the number of atoms present in the unit cell, we can arrive the formula of the compound of the substance. Formula is very important in understanding all the properties. Just like our name, formula is very important. So to know the formula, we need to calculate the number of atoms present in a unit cell. So let me consider the simple cubic. We know 8 atoms are present at the 8 corners. Just now I told you that in SC unit cell, an atom at the corner is shared by 8 unit cell, not only in this unit cell, this is present in 8 unit cell. So for this unit, the share of this atom is only 1/8, 1/8 only, because it is shared by 8 unit cell. So likewise, all the 8 atoms are shared by 8 other unit cells. So what will be the total number of atoms in this unit cell means? So we have 8 atoms. Each atom has only 1/8 share only. So the total number of atoms present in the SC unit cell will be 8 into 1/8, because 1/8 portion only available to this unit cell. For one atom, 1/8. For 8 atoms, 8 into 1/8 equal to only 1. So number of atoms, total number of atoms in SC unit cell is only 1, not 8. Remember. So then we move into the body centered cubic unit cell. So here atoms are present at the 8 corners. So one type of atom, corner atom, again the same, 8 into 1/8 equal to 1. So one more atom is present in the body center, which is not shared by any other unit cell. So the whole share is available, the whole atom is available in the same unit cell. So the atom at the body center contributes fully. That means the total number of atoms in the body centered cubic lattice is 2. Coming to FCC. In FCC we have same 8 atoms in the corner. That means the same calculation. 8 atoms share 1/8. So total is 1. What about the atoms at the corners? There are 6 atoms, 6 corners, 6 atoms. But one atom is shared by 2 unit cell means for this unit cell, an atom at the phase center is available only half. So for this unit cell, this is only half. That means 6 into half means 3. So totally 4 atoms are present in the FCC unit cell. So SC unit cell, of course 8 atoms constitute the unit cell, but share for each atom the share is only 1/8. That means total number of atoms present is only 1. Likewise here BCC 2, FCC 4. So this is about calculation of number of atoms in cubic unit cell. This calculation gives an idea about the formula of the compound in which the unit cell is present. So this is an important calculation. Try to understand this.